Okay, let's get started. Week five is ending today, which means what do we have today at the end of class? In-class assignment, that's right. So, that's for credit. Where are we starting today? Where are we starting? Sign a sheet, make sure everybody signs in. Let's go to the instructions. Oh, let's get to the date. Today's the 7th, the end of week 5. Then we have Thursday, we start week 6. Then Tuesday, end week 6. Then week 7. And then, like one more lecture in the spring break. We're getting close. So now, let's look at the instructions for week 5 to refresh our memory as to what's due. You have a written assignment, an Excel assignment this week. They're due Thursday like usual. Here's the 2 PowerPoints we're using. We're going back kind of towards the beginning a little bit with the slides. And the written assignment we talked about on Thursday a lot. And what we talked about them is where they're located. If I recall, like number 1, A and B was to answer the question about which numbers you would add up together to answer the question. I think it was just about, that's all that was. Number 3 was all about you taking a frequency table and turning it into a relative frequency table, if you recall, showing all your work. But it was number 5, which was the one that I thought might be the tougher one, where you're given a relative frequency table and you got to show the work to convert it back to frequency. So those are the 3 problems on your written assignment. Those won't take that long. The only one that I'm going to give you a hint, number 5, and I think I already gave a hint last week, converting from a relative frequency back to frequency is all about using the number of total responses. The total number of responses is the key to that, which is given in the description of the problem. So there's my hint. So what do we have? 1A and B, 2A only, 5A only. That's it for the written assignment. But most of the points are in the Excel assignment, which is right here. Watch this, I'm going to make it real small. You can just see everything at one time here. You have all this data, you have all these yellow boxes to fill in, which we're going to talk about, all the way down to here. And most of your points are on this line right there where I'm going back and forth. What's the number on that? You might as well write a note. Most of the points are in line 30. Line 30 is where most of the points are at for your homework assignment, right there. Just to talk about a couple here. The first one's asking you for the mean of data. We've all done this already. What the key is that you're using the correct data entry cell locations. You want to make sure you use this top corner cell location to represent the data, and then the bottom right corner. That's the cell locations you want to use when you're describing what you want Excel to look at to find the mean. The second question is asking you for the largest number. Now, I expect some of you to use one Excel function we learned, and some of you use the other Excel function we learned, but it's up to you. We learned 2 different ones that you can find the largest number. Here, you have to use an Excel function equation to find the smallest number, and again, we learned 2 different ways, 2 different Excel functions to find the smallest number. So that will be there. This is the one where people start to go, oh, I'm not sure what to do here, and things get screwed up. But this one is all about you using cell locations. We're recording this, so I'm making sure you realize cell locations is the key to this cell right there, where you're taking the cell location where the largest number's been calculated, which happens to be up here, whoops, right here, I'm sorry. And then you subtract the cell location where the smallest piece of data is located, which happens to be right there where I'm circling. And then you're going to divide it by the number of classes in the sentence here. And it happens to say 6 classes. You're taking all that data and you're going to split it into 6 classes, which you're about to learn how it's done. And once you take this number calculation right there and decide what that is, you're gonna use that number to make your 6 classes starting at the number 100. That's the only number given to you is the number 100, and then you have to decide what the end of that class will be. So every class has a small number and a large number, and it represents all the numbers between those two numbers in that class. So each one of these 6 classes are gonna be different. Now I'm gonna explain that by doing this. Hypothetically, let's pretend this was 142.1. And it says round it now to the closest integer and use that for your class sizes. Now I want to tell you for sure, there's no way it could be 142.1 because I know this is going to make this way too large. So this is just hypothetical. This is not what that's going to turn out to be. If we round this properly, would I use 142 or 143? 142. So now I'm going to use 142 to create each of my classes starting with 100. So right there, if I had a calculator right now, anybody finds this really easy, help me out by getting a calculator out, I may need it. I'm going to add 142 to 100, and this is going to be my ending class. So 142 plus 100, this is an easy one, 242. I got the first class done. Now when I hit enter, let me scroll this spreadsheet up. It changes, it puts the class in 2 other cells down below. Come on. It won't scroll until I finish this. Darn it. Enter. Okay, now scroll it up. Look at how it says 100 to 242 here and here. But they're not highlighted. These are set up to automatically, once you make a class, lower range, upper range, it's going to put that class in these 2 cells automatically. Now, the next class, start it 1 above where the previous class ended. Now, if you understand what I said, where does this class start at? What number? Say it loud, please. 243. 1 number above where the previous class ended. So I'm going to start this one off instead of a question mark. 243. Get rid of the question mark. Now I got it. Where does it end? Whatever 243 plus 142, because that's our class size we determined, equals. So 243, 343, 383, 385. Does that sound right? I don't have a calculator. 385. Now when I hit enter, all those question marks below there are going to turn into that range. There it is, 243 to 385. There's the second class. Is everybody getting the handle of this? I want to make sure you got it. I'm not going to do all 6 classes, but I'm going to make sure you get it. What would be my first number of this particular class? 386. What is it? 386. Very good. 1 above where the other one ended. 386. 386. Get rid of the question mark. And then, you got to do the math on this, but where would it end? Here we go. 386 plus 142 makes 486. 526, 526, 527, 528. Someone's got to check that. 528. Am I close? Sure. Really? Yeah. Great. And there it is. Change it below. There you go. Now, here's how you kind of confirm you did it right. You have to ask yourself this question. Is the smallest number going to fit in that first class? Is the smallest number truly between 100 and 242? And the answer is going to be yes if you're doing it right. And then you go to the last class, way up here, this final class up here, and you ask yourself this question. Is the largest number in between that last class range? Whatever that last class ends up being, that largest number should be in that class if you did this right. That's the whole point of making these class sizes. The exact same size, and that the biggest class is going to have that largest number, and the smallest class is going to have the smallest number in it. And that's the proper way of doing it. Go ahead.
So the size of each class, is that the range?
It's going to be the kind of the range. I don't know, is it? If I take 242 minus 100, yeah, I guess it is the range, yeah? That would be the range of every class.
I mean, the range for the data.
No, it's not the range for the, yeah, that is the range. No, it's the range from the data divided by 6 because we're using 6 classes. That's the 142. If we didn't divide by 6, it would be the range of the full data because it's the largest minus the smallest, yes. But you don't have to use that usually, define that spread, what you're going to make each class. You don't have to use the max minus the min like we did for range. You just have to use the cell locations where the largest number is and where the smallest number has already been calculated and subtract those two cells. Then divide by 6. Put those parentheses around that subtraction. That subtraction has to be done first, then divide by 6. And then you just do the appropriate rounding to determine. If we all do this cell right there, what is that? I-19. If we all do I-19 the exact same way, then the spread of each of our classes, the numbers at the start and ending and beginning numbers for each class would be the exact same for all of us. That's what I'm trying to accomplish.
So if it was 25, what do we do?
So if you divide by 5, is that what you just said?
No, if it's 142.5.
Oh, yeah, what's the appropriate rounding? Would you use 142 or 143? 143, because the next digit is a 5. If the first digit to the right of the decimal is a 5 or above, you've got to round up. 4 and below, you keep it to that number. All right, now you know how to do classes. Let's get to the formal part of classes here. No. Now we're going to talk about randomness, random sampling. I want to remind you of this story. This is the one where the car shop, this auto repair place, is talking about, hey, we might be charging too little or spending too much on parts for tune-ups. What is it called? Hudson Auto Repair? So they said, we want to find out what the average amount of money we're spending on parts for tune-ups is, and we're going to use a random sample. How many did they have their sample? These numbers look familiar, right? There were 70, I think. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 50. 50. So they said, we want to get a random sample of the average amount we spend on parts for tune-ups. So here's what they did. We want to get a sample size of 50. And by the way, the golden rule in real statistics is that usually, if you can, have a sample size of 30 or more. That's kind of the key. Also, the larger the sample size, the more accurate your sample is telling you about the population, about all the data. So in this case, instead of using 30, this manager is using 50, which is a pretty nice size sample size. Even though, let's pretend, hypothetically, that we have file cabinets here with 1,000 invoices in them. We don't have time to pull out all 1,000 and figure out the parts that we spent for every one of those tune-ups. So we're going to use a sample of 50 instead. Now, when you do random sampling, how it's done in the real world, it's all about, here's the rule, that the random sample is selected in a way that every item in the population has an even chance of possibly being part of the sample. Did everybody hear that? I'm going to say it again. Whatever the process you choose to do random sampling, to check, to figure out which 50 you're going to use out of those 1,000, whatever the process is, the rule is, I would be determining whether that process is correct or not, as long as your process is allowing all 1,000 of the invoices to have a fair chance to be one of the 50 you're picking. So whatever the process is, when I say a process, here's what I'm going to make up off the top of my head. I'm going to go ahead and assume that there's numbers on the invoices, and there aren't, but let's assume there are, and that these invoices are in order from 1 to 1,000. Like the top left-hand drawer, the first cabinet, there's like 4 drawers per cabinet. So maybe this has 1 through blankety blank. The next one has blankety blank through blankety blank. And if I went to the bottom right-hand cabinet, it would be blankety blank to 1,000. And let's say they're numbered. So now I got to figure out a way to pick out 50 of these numbered 1,000 invoices that gives every one of them a fair chance to be one of those 50. That's the key to random sampling. That's how you get true information in your sample about the population. If every one of the items in the population don't have a fair chance to be in that sample, and the sampling process has some bias involved, it screws up everything. And the true results you get are steering you away from the truly what's going on in the population because of the process in which you did the random sampling was not fair. Now, there's a million ways we could come up with to give every one of these 1,000 invoices that I'm looking at in my mind. I hope you can see my picture. Giving every one of them a fair chance to be one of those 50, we can come up with all kinds of ways. So what I thought is, I want you just to give me a number between 1 and 1,000. Just give me the first number that comes off the top of your head real quick, someone. 685. There it is. How random could that have been? He doesn't know anything about these invoices. He has no idea what 685 invoice is going to be. It was the first thing that popped in his head when I said, give me the number off the top of your head, right? So now I'm going to go to 685 and pull it out. My question for you is, using a human, that was the tough part about this, by the way, using a human like that to come up with a random number, because he didn't know anything about them, I think that may have been a fair chance where all 1,000 of them could have possibly been one of the ones I selected. But I want to get the human out of it. By the way, most things screw up because of humans, just so you know. All right? Things that happen are because of humans. If you can get the human out of the equation, you get a lot more accuracy. It's the human that causes the problem. So, with that said, let's see. We haven't learned this yet. Oh yeah, hang on, I opened it up. Where is it? When I was in college, when I was your age, and I thought I knew everything, and I'm sure you do too. Well, Excel didn't exist yet, it wasn't invented yet. Lotus 123 wasn't invented. By the way, Microsoft Excel ripped off Lotus 123, just so you know. Those were every business used spreadsheets, Lotus 123, before Microsoft came out with Excel, just so you know. Anyway, before they were invented, we had to use what's called random number tables. And our professor would say, okay, everybody, go with random number tables page, let's call this page 50. And there's how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns there. And then the professor would say, he or she would go, use column 3, and since, oh, wait, I want to make things easy. Pretend we only have 999 invoices. I don't want to go to 1,000. I want 3 digits, right? 901 through 999. The biggest number has 3 digits. So the professor would say, use column 3, the first 3 digits starting from the left until you find 50 good numbers and pull those invoices out. Now look, this booklet you had to buy when you're in stats back in my day was only about this thick, but every page looked exactly like this. And so there's no way anybody would know what random numbers you're about to get by picking a random column on a random page of this whole book of random numbers. And so we look at column 3, you tell me, what's the first invoice I'm pulling out now? What is it? No. No. We're only using the first 3 digits to the left. 891. 891 is the first one I'm pulling out. Now here's the deal. With random numbers, you may get 891 again. It's just how these pages work. But we knew that if you get the same number again, you keep moving on to the next random number until you finally drew 50 out. Because we knew we wanted 30 or 50 or whatever the number is you're going to put in your sample. What's my second one I'm pulling out? I got to look. Let's hear it. Come on, where's the hesitation? 7, what? No, we're using column 3, the first 3 digits of these random numbers, and we're on the second number down. What's my number?
756.
756. That's it. 756 of 756. I just pulled out. What's my next one?
407.
407. 407. I'm pulling it out. Next one.
649.
You get it. You get it. That's how we used to have to do random numbers back in the day. But notice we're using 3 digits. If you go down there, we would go that column all the way to the bottom, and we'd go to the next column and keep going until we finally found 50 good numbers. If that was our sample size. My question is, with this process, and by the way, there could have been a 001, right? The first 3 digits of somewhere in there, there's a 00 something. There's a 083 in the 4th column. I see you jumped out at me. So what I'm trying to say is, using a book of random numbers like this was the old process we used that would give all 999 of these a fair chance of possibly being one of the 50. In about a week or 2, we're going to learn how to use Excel to pick the random numbers, because now everybody uses Excel to come up with random numbers to do the random process. Because Excel invented an equation that you tell it what's the smallest number it could be chosen, what's the largest number, and it will randomly pick a number between those 2 for you. And Excel is just like a page of random numbers. Sometimes it repeats the number, and you go, wait, we just pulled that one. Okay, we skip to another number until you finally get 50 good numbers and you pulled out 50 of them. That's the random process. And there was a million different ways of doing it. There's a million different ways how you could have came up with the random numbers, but as long as whatever process you come up with gives every one of those, in this case 999 of them, the fair chance of possibly being those one of the 50 that you pull out. That's what you got to come up with random sampling. Okay, so now we're going to PowerPoint 2. Picking up where we left off. Here we have those same 50 tune-ups. There's the 50 we pulled out. The 50 invoices, we added up the cost per parts on every one of those tune-ups, so there they all are. Someone tell me what they think the largest amount of money we had to spend for a tune-up is on parts?
105.
How much? I hear 109. I think it's 109.
Oh, 109, yeah.
Is there something bigger than 109?
No.
What's the smallest amount? I see something lower than that. 60. I heard 62. 52. I think 52 might be it.
52.
I don't see anything lower than 52. Glancing fast. Okay, now you identify just like you're going to do in that spreadsheet, but that spreadsheet has more than 50 numbers. So you're going to use either whatever the Excel function you decide to use to find the largest number, whatever the Excel function equation you decide to use to find the smallest, because you learned two different ones. But then you take them and you're going to do this and make classes. You're going to make classes. Here's the deal with making classes. Here's the requirements. Classes are usually only between 5 or 20 of them, depending on how much data you have. The least amount of data you have, if you have a small amount of data, you want to go with small amount of classes, like 5 classes. If you have a huge amount of data, you want to go with as many classes as possible, which would be 20 classes. So the more data, the more classes, but there's no rule of thumb. It's like one person may say, well, with 50 pieces of data, I want to use 5 classes. And another person may say, yeah, that's a small amount of data, but I want to use 6 classes. That's fine. There's no like strong rule of thumb. The only rule of thumb is if you have a small amount of data, you want to use a small amount of classes. What you want to avoid right here on the third one is smaller data sets usually require fewer classes. Wait, where is it? Don't use so many classes that some of the classes contain very few data items. That is the most common mistake right there. That last bullet point is that some people will use too many classes for not enough data, and some of the classes may only have 2 or 3 pieces of data in it, where other ones have like 10 or 12 pieces of data in it. So that means you're using too many classes if you see that. That is the most common error. All right, there's the other benefits to it, but let's go to this. Here's the formula. Put parentheses around the numerator, please. The largest value of the data minus the smallest value of the data divided by the number of classes you're going to do. I will always give you the number of classes. Like on that assignment that's due tonight?
Tomorrow.
Just check. Thursday. Okay.
Thursday.
You sure it's not tonight? Thursday. All right, just check. Thursday. That assignment's due Thursday. You're being told to use 6 classes. So you don't have to come up with, should we use 5, 6? You use 6. So you know you're dividing by 6 in your equation.
Rounding just up or down, or?
Yes. Appropriate rounding, whatever that first digit to the right of the decimal is, you decide whether you're rounding up or down.
Okay.
Okay?
So when you were doing it earlier, you just put down a random number?
I put around 124.2. That's not the real one. 142, what did I use? 142.2 or something like that? And then we rounded it to 142? Yes. That was hypothetical just to show you how to make classes.
Okay, that makes sense.
Okay? You're going to come up with a number, by the way, it's going to be less than 142. I picked a big number on purpose.
No, it's
So here it is. You guys said 109 is the largest number, 52 is the smallest number. Subtract those. We're gonna this data. We're gonna decide to use 6 classes here. Just a coincidence that this is 6 classes and our assignment 6 classes. Purely coincidental. Turned out to be 9.5. We round to 10. Here's the bad news. This PowerPoint is not doing it the way I'm trying to get you to do it on the spreadsheet. Look, if we start at 50, you add 10, it would end at 60. Then we'd start at 61 and add 10 if we did it like the spreadsheet. So what's happening here is, pretend this equals 9, not 10. Now it's being done exactly like I wanted you to do it on the spreadsheet. Start at 50, add 9, we're at 59. Start at the next number, 60, add 9. There it is, 69. Start at the next number, 70, add 9. Everybody get it? So pretend this turned out to be, look what I'm gonna do. I'm gonna just pretend that that's a 2. There we go. There. Now that makes this a 9. There. There you go. I don't have to explain that any more semesters. Except someone's going to say, hey, that doesn't equal 9.2. No one's checking, are you? I didn't see any of you check that. Thank you. Hey, I just corrected it. There you go. Now you're doing it just like I'm trying to get you to do it on the spreadsheet. I'm starting you at the number 100 though. This, pretend like all you see is this starts at 50, and you know every class is 9. So you start at 50, you add 9, you get to 59, you start at the next number 60, add 9, takes you to 69, start at the next number 70, add 9. Everybody get it? So whatever number you get, you treat it the same way, but you're starting at 100. Add, start at the next number, add, start at the next number. And you're doing all 6 classes. So you can see, we got all the way to the 6th class, we're starting at 100, adding 9, go to 109. One second. Does everybody see this? Ready? Is the smallest number fit in the first class? Yes or no?
No.
What's the smallest number?
Oh, 52.
52, which fits between
50
50
and
and
59.
59. So it is in the smallest class, right? Is the largest number in the last class, which is 109, and it is. It's right there. That's a hint that you did it correctly. If you're, now I want to tell you, a big mistake is that last class doesn't end big enough to allow that largest number to fit. That means you may have made a mistake or something. Let me go here and then here. Go ahead.
I wanted to ask about why didn't we start with the 52? Like why didn't we start with
I
the lowest
just
number?
want to start with the round numbers. All just like
Yeah.
the data on the homework starts at 100 on that class. Your smallest number is not going to be 100, just so you know.
Yeah.
Okay. So the same thing's going to happen. Okay. All right, guys. So we're at that point in the spreadsheet now where you're forming the classes. All right, now I'm skipping a part where you write either count or Countif equations to go look at the data and count how many are in each class. So that's what's happening here. If I go back to these 50 pieces of data up here, and I say, okay, how many are between 50 and 59? Well, there's 52, there's 57, we can keep going. Is there more than 2? I forgot what it said. Is there only 2? Look, there's only 2 there. Anyway, right there should be a suspicion. Hey, am I using too many classes? There's only 2 in the first class. Let's keep going though. So 2, you're gonna write an equation that comes up with these numbers. I wanna go back to the spreadsheet. I don't wanna lose anybody. I wanna make sure you're with me on this one. Let me make this big. Okay, I'm talking about this row right here, number 30. You're writing 6 equations, either using count or Countif, and there's several different ways of answering these, so I don't expect everybody to have the same number, same equation. There's several different ways of doing this. When you learn how to do count and Countif here in a few minutes, you'll see. But I expect equations in each of these 6 cells that are gonna go up at the data, count how many are between 100 and whatever your end of your first class is. How many are between 200 and something and whatever the end of your second class is. And the hit is, this equation right here will add these 6 cells together. And as long as that total equals the number of pieces of data up there, so, you know, figure out how many pieces of data you have up there, which I believe is 80 some pieces of data. However many you have, if it equals that number, you probably did your count and Countif statements correct then. You probably have the right count there. So leave that cell the way it is, but this is your check and balance to see if maybe you did these correctly. That's where we're at. I'm about to teach you how to do those 6 cells, which is where most of the points of this assignment is. But before we do those 6 cells, these last 2 rows, this is where once you have the frequencies, and I want to go back to the PowerPoint. See how we have the frequencies right now? 2 are in that class, 13 are in the second class, 16 are between 70 and 79. By the way, what is the most common amount of money we pay for parts for these from all these invoices, these 50? Between what? 70, 79, exactly. Once you have these frequencies, you're now going to turn it into either relative frequency or percent frequency or both. It's up to you. On the spreadsheet it says, do this row if you want to do relative frequencies, do this row if you want to do percent frequencies, or you can do them both for practice. It's up to you. Go ahead.
Where do we get the frequencies from?
Where do we get what?
The frequencies.
Right here?
The equation.
Right, what I'm pointing at right here?
Yeah.
Those, we went up there and counted. We went up there and said, okay, how many are between 50 and 59?
Oh, okay.
And we just manually counted them right now. But you're about to learn how to use an Excel equation to go up and count them instead. That's what you have to do. There was another question.
The formula? Where's the formula? The frequency distribution formula?
Where's that at?
Up. Just one slide up.
No, that.
What
hang
is
on.
this? What is the
No,
other?
that's define the class. That right there?
Yeah.
That's define what size each class will be. This formula is just defined the class size. So we found our class sizes should be 9.2, we rounded to 9, and then we made each class 9. That's all that formula is doing. That formula I showed you is for cell, let me get back to your cell spreadsheet. I wanna make sure you guys realize where you're using that formula I just showed you. It's right there in, what is that, I-19. That formula I just showed you is for I-19, but you're using the cell locations to subtract, put parentheses around it, divide by 6, okay? But before we go into the count and count ifs, these last two lines, let's pretend that this is, I don't know, 10. Let's pretend there's a 10 there. Well, why is it in the center? There. Now, how will you do this relative frequency? You ready? Oh wait, I gotta put more numbers here. Let me make this one 21, there. Watch how I'm doing relative frequency. I'm using cell location. Equals, 10 is in the cell E30. E30 divided by the total of all the data is in R30. R30. There's the relative frequency right there. 0.322581. And that's it, you're done. You don't need to move the decimal or anything because you're doing relative frequency. You're not doing percent frequencies. I want to make sure you get this. Someone help me with the next one. I want relative frequency with using cell locations equals, give me a cell location. G30, very good. Divided by R30, very good, very good. You guys are with me. Now, if you want to do percent frequency, just do the same exact E30 divided by R30, but then times 100. That's the only thing. So I'm going to do it now down here. What is it? R30, E30 equals E30 divided by R30, but now I'm multiplied by 100. That's the only step I have to add to turn it into a percent frequency. I'm moving the decimal 2 places, times 100. There it is. Instead of 0.322581, it's 32.2581.
Can we just write E35 times 100? E30. Can we just write E35 times 100?
Yeah, but some people aren't going to do the relative frequencies. They're only going to do the percent frequencies. You don't have to do both those rows, you guys. You can do one
just
or
one
the
of
other.
them.
Just one of them. That's why I have an or between each one of them, because you can pick whichever row you want to do. You can mix it up. You can do 2% frequencies and 4 relative frequencies. It's up to you. I think for practice, you might consider doing both, but it's up to you.
Could we do that though? Just use that cell and then multiply by 100?
You can, if you decide to do all these relative frequencies and you just want to use the relative frequencies times 100 to do percent frequencies because you're doing both of them, yes, absolutely, sure. But if you aren't doing relative frequencies, that won't work. It won't. You have to use the cell locations from above. So, all right, how are we doing? Are we at this point? Are we at this point? Are we really at this point? How are we doing? We got a lot of time ahead of us. But here it is. This is it. Count and count if. I gotta make sure we're at this point. I wanna make sure I'm not skipping anything. Huh? Here, I wanna show you this at least. Hang on. Page 6. I can't get this mouse to work. Darn it. Whoop. Hang on. Where is it? There it is. Switch to PC. Now minimize. Page 16, bottom of the page, right there, B. This gives you, I'm about to teach you count, but there's a good description of it there. Page 17, top of the page, where is it? C. This is a good description of count if, but this is what I'm about to teach you, but you also have reference there. So pages 16 and 17, bottom of 16 is count, top of 17 is count if. So you can have additional descriptions there. Meanwhile, let's get back here now. Where is it? Right here? Right here? Let's start with sum. Everybody's used sum. Equals SUM, parentheses, that's B8, B21. Can everybody see that? I'm going to make it bigger. I don't know. Will that make it bigger? It won't make it bigger. B8 ... B21 parentheses. Here's the data, B8 through B21. Sum will add all the numbers. Look at how some of the cells have numbers. We've seen this before. Or letters, excuse me. it will ignore the cells with letters and just add the numbers up. It will sum all the numbers up. You've all used sum before, I think. SUM. Just in case you haven't, there it is. Now, count equals COUNT parentheses B8 dot dot B21 parentheses. It's going through all that data from B8 to B21 and counting how many cells have numbers in them, not words, numbers. So the word count just counts how many cells have numbers, which is used a lot when you want to divide by however many cells have numbers and try to ignore the cells with letters. So there's how many cells altogether here with data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I think, 14 or 13, and 11 of them have data. So that means 3 without. Let's see, AB's there, EE and AB. So there it is. We have 3 without data. They have letters. So 11 have that. Okay, there's that so far. Now, count if. Count if has cell locations just like sum did, just like count did, but then it has a comma, and you have the criteria. You're telling Excel what it is you want counted. That's the difference with count if. You're telling it what is it you want to be counted. And you tell it in ways like this. You'll see a lot of suggestions on page 17 at the top, but notice what I'm using here. A quotation, then a greater than symbol, then the number 30, quotation, parentheses. So what I'm asking Excel to do is go look at all the data between, look at all the cells between B8 and B21 and tell me how many of them have a number greater than 30 in them. And out of those 14 cells, 8 of them had a number greater than 30. Let's count them. Greater than 30. Not the first one. There's 1, 43, 432, there's 2, 122, there's 3, 871 is 4, 53 is 5, 122 is 6, 400 is 7, 1209 is 8, and that's it. 8 of them that were greater than 30. Watch this. If I put less than, how many were greater than 30? I forgot. 8? 8. So if I put less than 30, unless there's a number 30 there, we should get the how many should be less than 30. If there's 8 greater than 30, how many would be less than 30?
5.
What is it? 14 from 8 leaves 6 minus 3, because 3 are letters. Should be only a 3 then. Let's take a look. Whoops. There it is. 3. All I did was change it to greater than 30. What if I change it to equals 30? There's equals 30. How many should be there? 0. There it is, 0. Watch this. What if I change it to equals AB? Get rid of the 30. Look, it's not even a number. Just equals AB. Is there 2 ABs in that data? Sure is. What was that other letter? What was it? It was EE, the C. Now look, I'm not even going to use uppercase. Let's see if it recognizes EE. Even though in the data it's uppercase, small case E, I'm just telling it EE, both lowercase. It's either going to say 0 or 1 if this works. 1. So it's recognizing the EE without even telling it one of them's uppercase. All right. Now, I'm trying to think if there's any other way I want to show you here. You know it does words, you know it does numbers, greater than, less than, equal to. Let's go to this one. Equals count if B8 through B21, comma, greater than symbol 20, minus count if, parentheses, B8 through B21, comma, greater than 54. So what I want you to think about is one of these equations at a time. However many numbers are greater than 20. And it looks like, I think they're all greater than 20, but 3 of them don't have numbers. So that would be 11. 11 of them are greater than 20. Does everyone agree, or is there a number that are less than 20? Does it say 20? Does it say 20? So right now we're at 11. Then it says, okay, how many numbers are greater than 54? So let's see, 432, 122, 871. What are we saying? Greater than 54. 122, 400, 1209, and that's it. So 6 of them. So if you take 11 minus 6, you just found how many are between 20 and 54. Actually though, this is really not, it's between 21 and 54. Let me make one change here to make it between 20 and 54. I'm gonna add an equal symbol. Didn't change the answer though, there's still 5 numbers between 20 and 54. Everybody see how I found how many numbers there are between two different numbers? Let's do it again. Tell me what I would change. I want to make sure you're getting this. If I said, hey, I want to know how many numbers there are between 1 and 30. Between 1 and 30. Including 1 and 30. Including 1 and 30. Let me say that again. So what do I have to change there? Do I have to change the cell locations at all? No, the data's in the same place. What about the criteria? What is it about the first criteria? Right now it says greater than or equal to 20. What does that need to be changed to? That's all it needs to change, the 20 to a 1? The equal sign can stay? Say it again. Change it to 30? Okay. 30 or 1? We better vote on this.
What was the question?
Okay, what is the question? You ready? Right now, this equation is finding how many numbers are between 20 and 54. I want it to change, let me put it on the board. How many are between 1 and 30? Let's say that's our first class. That's our first class of the data, and we want to know how many fit that class. What is it I got to change up there? That first number there, that 20 needs to change to a 1? Or does it need to change to a 30?
You said 30.
1? Some say 30. Let's try 1 first, then we'll try 30. All right, now what else has to change? Anything over here? What about here? Now, let me say this again. I want to know how many are between 1 and 30, including 1 and 30. Including 1 and 30. Now here, you got to think about this hard because I'm trying to lead you into making a mistake. Go ahead. This is the mistake I'm trying to lead you to make. But here's the deal. If I put an equal there and there's a 30, we're subtracting that 30 out because this is a subtraction of how many are 1 and how many the other. So the right-hand equation actually does not have the equal. Only the left-hand equation does. The one you're subtracting from. So in this case, all that has to be done is a 30. Now, I'm going to change the data and put a 30 in there so you can see what happens. Not right now, but I want you to see the answer to this. What should I get as an answer? If we look at this data, how many are between 1 and 30? I got to stare at it for a minute. I see the 23.
3.
I see another 23 and another 23. That makes it easy. So 3. So the answer should be 3 if we did this right, correct? There it is. Now, I'm going to change this 23 to a 30. And if I do, our equation should go to 4. You agree? Well, this equation we just wrote is finding how many between 1 and 30. If we wrote it right, it should include, well, no, that's right, 23 is already in it. Let me take a piece of data that's not in it. You're right. Hang on. Let's take 122 and turn it to 30. Right now, 122 is not in there. So here we go. I'm changing it to 30. So that 3 should turn into a 4. Oh, how did that work?
Wait, how? There's no equal sign.
Now hang on. Yeah, right now there's no equal sign. So it worked. But now I'm putting the equal here. If I put the equal here, we still should get a 4, but it won't. Because it's going to subtract that 30 out, it will go back to 3. Let me show you. Put the equal. It went back to 3 because now it subtracted the 30 out because we had that equal in the last one. So on the ending equation, what you're subtracting out wants to be the number with just the greater than, so that number's included in the data that stays, that's in the subtraction. I know that sounds crazy, doesn't it? But the first number, let me show you what happens now if we don't have the equal sign at the beginning. Is there a 1 in our data? There isn't, is there?
No.
So right now, let's say I just switched it, so we're back at 4. Let's see, what number can I make a 1 here so we can do this? I'm gonna get really confused. I'm gonna make that a 1. Okay, because we have that equal sign there, it included that 1 in the data now. But watch what happens if I take the equal sign out. That 1 will be subtracted out of the data now because all it says is greater than 1, not greater than equal to. And that will go back down to 4. There it is. So it's accidentally not including the 1. So the left-hand side, whatever you're subtracting from, has to have the equal sign. And the right-hand side, whatever you're subtracting, does not have the equal sign. I know, it sounds crazy. I'm putting the equal sign back in, because we know there's 5 numbers between 1 and 30. To answer your question, go ahead, Al.
So does this always do it for the left side?
Yeah, whatever, yes, the left side, because you're always subtracting. You want to have that equal sign in most cases. Here's where it may be different. Some people use greater than and greater than, and that may change which one gets the equal sign possibly. And you gotta then have the 30 in front and the 1 on the right if you're going greater than, so you end up with a positive number. I don't want to confuse you though. I want you to focus on the one I'm teaching you, that we're using both less thans. But if you are real interested in this Countif, try experimenting, swapping them and switching them to greater thans and putting one with equal, both with no equal. Test it out and use a small amount of data so it's easy for you to see whether it's doing it right or wrong. So you can see how it works. But at this point in time, my big hint is you use greater thans instead of less thans. Use greater thans instead of less thans. You put the smaller number on the left, the bigger number on the right, and you include an equal on the left-hand Countif equation. That's my hint. Go ahead, there was a question. I missed who had their hand up. Go ahead.
So in the first one, between 1 and 30, can we just put, Countif, less than 30?
Yes.
That's not-
Everybody hear he's saying because the first class is 1 to 30, he's saying, can we just make the first one, instead of doing this whole long equation right here, define what's between 1 and 30, just since it's the first class, just however many are 30 or less, right? So let's do that. Ready? Equals, now we're just using count, and that's why you could either use count or Countif for line 30, because that one. And the ending one could use just count 2 with his philosophy of just using count on each of the end. But the 4 in the middle, you have almost no choice but to use Countif. Don't get me wrong, you're okay if you want to use Countif on the first one and the last one, but if you see the big picture and you want to use just count, which I'm about to do right now, equals count, if, excuse me, no, you're right, I gotta have an if, but he's saying just one equation instead, too. My bad. Equals, what is this again? B8 through B21? B8 dot B21 comma. Now he's saying just put less than 30, or really less than equal to 30, I believe, right? Here we go. Less than, oh, I forgot the quotations. Less than, equal, 30, end quotation, parentheses. So if this is right, how many numbers are less than 30 up there? I see at least 3, 4 now. I see 4. Is that right? Is there more than that? Help me out. There's 5 less than 30? Oh, 1's equal to 30. I see it now. So this should be 5 if we did this right. We have no second equation, only because we have to be on the first class. Is this going to work? There it is, 5. Because it was the first class. That's why that worked. Go ahead, there was a question. Go ahead. Someone have a question? No? Do we feel like we can do line 30 from the Excel homework? Where all the points are? Has anybody got it done? You got it done? You raised your hand before I said that. Go ahead. You test it out. Try it with the equal sign, try it without. Test it out. You got sometimes you do, sometimes you don't.
Like, would it be safe if I just did it every time?
What if you said what?
If I just did it every time, would it be safe, or?
I don't know. I'm not sure. And sometimes it all depends if a number lands right on the one of the upper or lower end of your class. You experiment with it. Here's my hint. Don't forget, your frequency should add up to the total number of pieces of data, and that's usually the way you know you did it right or not. Does anybody know how many pieces of data there are? Go ahead. 84. So if your frequencies add up to 84, then you probably did it right. Cole, you got to finish? Oh man, don't tell anybody that. You ready for the in-class?
Yeah.
Are we ready?